So, hello and welcome back again to this online course on fundamentals of composites and cellular materials. So, in the last class, in fact, for the last couple of classes, we are talking about mechanics in composite materials. So, in the first class of mechanics, we discussed about longitudinal loading, and in the second class of mechanics, which discussed about transverse loading. So, in this today's class, I will continue on the transverse loading. I will give some more information on the transverse loading, and then we will try to solve certain problems where we can use these equations which we learned when there is longitudinal loading or transverse loading, and when the fibers are all continuous. If we have certain problems in those aspects or in those conditions, then how do we solve those problems? That is what we will discuss as well in today's class. So, let us continue from the last class where I was talking about transverse loading. So, I mentioned about this particular case that we can use this particular equation sigma LT sigma TTU, where basically sigma TTU is the transverse stress being experienced by the composite material, the maximum value of transverse stress, and that we can get from this equation sigma mu over K sigma. And then I mentioned that K sigma is basically we calculate from this particular equation where the fibers arrangement has been considered in a matrix as a square array. All right. We also discussed that obviously transverse modulus increases non-linearly. So, it is not linear relationship anymore, it is non-linear with increasing fiber volume fraction, and this is also quite understandable that transverse modulus is lower than the longitudinal modulus, and it is mostly influenced by the matrix modulus. We also can see from this particular equation that sigma T, or the transverse stress of the composite material, is basically controlled or mostly depends on sigma mu value. Okay. Similarly, like the modulus value. In case of modulus, it is and we are talking about transverse modulus, that is mostly influenced by the matrix modulus. Similarly, the transverse stress of the composite is also influenced mostly by the value of sigma mu, which is the ultimate stress, tensile stress of the matrix. Okay. So, now let us see some particular cases where we have unidirectional continuous fiber and 0 degree lamina. What do we mean by that actually? Okay, is that, so let me go to the board now, okay, and let me go to the next page. Okay. So, we are talking about a lamina like so, let us say like this, okay, and in that let us say this is the arrangement of fibers aligned, okay, and we are talking about continuous fibers and longitudinal loading. So, in that case we can think about two principal directions, and this is one and then we have direction 2, okay, and in that actually you can modulus is written as E11, and E11 is what already you have learned is that EF VF plus EM into 1 minus VF. Okay. Now, what is the if we have transverse loading like this, so in that case what is the value of modulus? We call it E22 is equals to what, or basically 1 by E22 you can write, but E22 would be equals to EF into EM multiplied by EF VM plus EM VF, right. So, now we can find out also the major strain, or from here you can get major Poisson's ratio, which is, you can write like nu 1 2, I am talking about longitudinal when it is longitudinal. So, 1 2 is equals to what? So, you can see here now longitudinal loading. So, it will be epsilon 2 over epsilon 1, and epsilon 2 is contraction. So, you can see here epsilon 2 is contraction. So, there will be a negative sign here. Okay. And this actually you can also write as VF multiplied by the Poisson's ratio of the fiber multiplied by Vm into the Poisson ratio of the matrix. Okay. So, that you get nu 1 2. Similarly, you can get the value of nu 2 1, which is basically the minor Poisson's ratio, nu 2 1, okay. And that nu 2 1 you can get from. So, now it is transverse loading in this direction. So, then it will be nu 2 1 is equals to epsilon 1 in case of transverse loading. So, epsilon 1 over epsilon 2, and again there will be negative sign, because now in the epsilon 1 is contraction, okay, as there is transverse loading. So, there will be contraction like this in the one direction. So, it will be negative epsilon 1 over epsilon 2, and that will be equals to this nu 2 1 will be equals to E 2 2 over E 1 1 multiplied by epsilon nu 1 2. Okay. So, from here you can get the value of E 1 1, E 2 2, also you can get the major Poisson ratio and minor Poisson's ratio. You also can get the value of shear modulus. So, now shear modulus would be both. So, you can see here you can have shear modulus like this. Let me use another color. So, like this, and also you can have like this and like this. Okay. So, you can have both this G 1 2 and G 2 2 and sorry G 2 1, G 1 2 and G 2 1, and both are, as you can see from this, both are equal, G 1 2 equals to G 2 1, and that you can find from the equation which says G 1. So, it is actually the G of fiber multiplied by G of matrix over G F V M plus G M G M multiplied by B F. So, you can get also the value of shear modulus from these equations. Okay. Now, so you can go through the slides which basically mentions about all these equations and explains these equations. Okay. So, ultimately what is happening here is that the longitudinal modulus is always greater than the transverse modulus. So, if you try to plot E 1 1 and E 2 2, how would it look like? Okay. In a single plot, if you try to plot E 1 1 and E 2 2, So, let me try to plot that. So, you can think about, so in this you have the Vf value, okay, and if this is our value of Em and if this is the value of Ef, then if you have longitudinal loading, it will be like this straight line, or let me use another color. So, this is for the red one is for longitudinal loading. Let me write it. So, this is basically E11. If we try to plot E22, how that look like? So, in case of longitudinal, it is linear, as you can see from this red line, but in case of transverse E22, it will not be linear, but it will be having a curve like non-linear relationship like this, and this is your E22. Okay. So, this is how actually the value of the modulus will change with respect to volume fraction depending upon the loading direction. If it is longitudinal E11, it will be linear relationship. If it is E22, it is non-linear relationship. Also, you can see from here that E11 is actually mostly dependent on the value of the Vf, volume fraction of the fiber, but E22 is mostly depending on the value of Em. It does not really vary that aggressively with the value of Vf, but it is mostly dependent on the value of Vm. So, let us see. So, you can see here that is how the graph E11 and E22, and as I was mentioning earlier, the longitudinal modulus is always greater than the transverse modulus, and the fiber contribute more to the development of the longitudinal modulus, and the matrix contributes more to the development of the transverse modulus. So, I was mentioning it earlier also that the fibers contribute more to the development of longitudinal modulus, but when it comes to transverse modulus, it is actually the matrix which contributes more. Okay. And the major Poisson's ratio, new one, to that we also saw in the last few minutes back, that major Poisson's ratio will always be greater than the minor Poisson's ratio. Okay. And as for E22, the matrix contributes more to the development of G12 than the fibers. This all we discussed just few minutes back. Okay. So, now let us try to solve certain problems. So, the first problem says, is it possible to produce a continuous and oriented aramide fiber epoxy matrix composite having longitudinal and transverse modulus of elasticity of 35 GPa and 5.17 GPa respectively. So, what it is saying that there is a particular composite material. So, let me now try to draw it, this particular case. So, let me go back to our whiteboard and we go to next page, okay, and we are trying to solve certain problems here. So, it says it is an composite material with aligned fibers like this, okay, and then both longitudinal and transverse modulus value has been mentioned. So, it says that E11 has been mentioned as how much? Let me find the value. It says 35 GPa, 35 GPa, and E22 has been mentioned as 5.17 GPa. Okay. The question is that can we have an arrangement of fiber and matrix so that we get this value. So, if you consider the first scenario E11 equals 35 GPa, so now we can write from, and also the values of Em and Ef has been have been provided. EM is how much given? EM is given as let me just check the problem once. It says that assume that the elastic modulus of the epoxy is 3.4 GPa and aramid fiber's value also has to be given here. Okay. So, let me write those values. So, EM has been given as 3.4 GPa, 3.4 GPa and EF has been given as 131 GPa. Yes, these two values are also given. Now, you have to find out that if this particular we can have a composite material where we have the value of E1 on this and E2 is this. Okay. So, this problem is quite straightforward problem. So, from here we can write that we know that E11 is equals to what? EF into Vf plus EM into 1 minus Vf. So, from here we can write E11 is 35 GPa equals to EF is given 131 multiplied by Vf plus EM is also given 3.4 multiplied by 1 minus Vf. And from here we can find out the value of Vf is equals to, it will be around equals to 0.25, approximately the value of Vf will be 0.25. You can calculate this equation from this equation and you get the value of Vf is 0.25. Now, there are two ways you can approach the next stage is that I can take Vf as 0.25 and then so from here I can do 1 over E C or E22 is equals to, as we know, Vf over Ef plus 1 minus Vf over Em, that we know in case of transverse loading. Okay. So, from here we can write that 1 over E22 is equals to Vf, how much we have got? 0.25 over Ef also you know 131 plus 1 minus Vf, which is basically 0.75 over Em is 3.4. Okay. And from here you can try to find out the value of E22 because and you will be seeing the value of E22 will be coming around 5.17 GPa. So, this 5.17 GPa is not equals to sorry not 5, so 5.17 GPa is required. Okay. So, this value would be coming around. So, this is my mistake here. This value of E22 would be coming in the range of around 4.5 GPa. Yes, and that is definitely not equals to 5.17 GPa. So, from here you can say that in this particular case this kind of composite material fabrication is not possible, because considering the same volume fraction, if we go into find out the value of E22, that is not matching with 5.17 GPa, which is the requirement. So, this is not possible. In other way also you can approach it, you can find out the Vf value also from this equation, putting the value of E22 as 5.17, and then from here you can find out this binomial equation you can solve to find out the value of Vf, and you will be seeing that Vf will be not be matching with this 0.25 certainly, and from there you can say that with these values of modulus of matrix and fiber, this kind of E11 and E22 value cannot be obtained. Okay. So, this was a very straightforward problem. Let us go to a new problem which is a little bit more involved. Okay. This problem says that a continuous and aligned fiber reinforced composite Okay. So, similar condition, it is continuous in fibers and having a cross sectional area of 970 mm square, and it is subjected to an external tensile loading. So, scenario is same, and if the stress sustained by the fiber and the matrix phases are 215 MPa and 5.38 MPa, then the force sustained by the fiber phase is this much has been given, and the total longitudinal strain is also given. And what you need to find out, the force sustained by the matrix phase, the modulus of elasticity of the composite material in the longitudinal direction, and the moduli of elasticity both for fiber and matrix. So, how do we calculate that? Let us again go back to our board. Okay. So, this problem says it has been there are certain values have been given, and what are the values given? It says that, let me find that problem. So, it says that, let me write down those points. So, it says that so again the scenario is similar, you have continuous fibers aligned and then longitudinal loading, and this cross section has been given now in this particular case is that 970. So, AC is given as 970 mm square, okay, and also the values of so sigma m and sigma f have been given. Sigma m has been given as 5.38 MPa and sigma f has been given as 215 MPa. Okay. These two values have been given, okay. And also the force sustained by the fiber phase, that means P f, force sustained by the fiber phase has been given as 76800 Newton, right. Okay. So, how do you solve this problem? So, in this case what you will do first, you know that sigma f is equals to F f over A f. So, that is equals to basically F f or P f, whatever you write. Okay, in this case, we are writing P f. So, let us write as F f. So, F f over F equals to F f multiplied by A f is what? V f multiplied by A c. So, now we know the value of sigma f, we know the value of F f, you can see from here, we also know the value of A c. So, from here we can find out the value of V f. V f is how much? Sigma f multiplied by, sorry, this is not by sigma f, but so V f is equals to F f over A c multiplied by sigma f. Okay. And from here you can put the plug in the values. F f is equals to how much? 76800, and then A c is given 970. You have to actually obviously mm square, and this is in Newton. So, all unit conversion has to be done, multiplied by sigma f is given 2.5 MPa. Anyway, from there ultimately you can calculate, considering the all the unit conversion, and then V f would be equals to 0.631, sorry, this value would be equals to 0.37, around 0.37. Okay. So, from here also you can get V m is equals to 1 minus V f, and that will be equals to 0.63. Okay. Now, ultimately you have to find out the value of F m. So, F m, because the load which are being carried by the matrix, that you have to find out. So, F m is equals to V m multiplied by sigma m into A c, and you can again plug in all the values. V m we know that 0.63, multiplied by sigma m is given 5.38, and multiplied by A c we also know 970 square, but you also have to take care of the units which I have not mentioned here, and ultimately F m would be coming around 3290 Newton. Okay. Then the next part says you have to find out the value of E c, composite materials E c, E, and that is equals to sigma c over epsilon. Epsilon I am saying, epsilon c you can say, but all epsilons are same isostrain condition. So, sigma c over epsilon, and that will be equals to so sigma c is what? That total load which is F m plus F f over A c multiplied by the strain. So, now we know the value of F m, we know the value of F f also, okay, F m, F f we can find out, and then A c is given already, and epsilon is also given as, so epsilon, the value of epsilon has also been given, epsilon is given as 1.56 multiplied by 10 to the power minus 3, in the problem it is given. So, you can plug in all the values, and then you can find out the values of E c is equals to 52 point. So, you can calculate all the values will be around 53 GPa. That is the value of modulus of the composite material. Okay. And similarly, you can find out the value of E m and E f as well, the modulus of matrix and the fiber. How do you get the value of epsilon m? Epsilon, sorry, E m. E m is equals to sigma m over epsilon m, okay. And epsilon m is known, epsilon m is nothing but this epsilon, and then sigma m is also known. So, then you can find out sigma m is how much? 5.38 MPa, okay, and epsilon m is given 1.56 multiplied by 10 to the power minus 3, this is MPa. So, from here you can get the value of epsilon m, E m, and the value of E m will be around 3.45 GPa. But one thing you have to be very careful is about the unit conversion. Okay. Similarly, the way you find out the value of E m, you also can find out the value of E f. Okay. So, here using the same equation you can find out the value of E f. Okay. So, you can see once the different values are given, okay, for example, in this particular case what is the thing you have to take care here is that the value of A c, that is the composite materials area, has been given. You have been given also the stress being experienced by the two different components, that is matrix and the fiber, and also the load being carried by the fiber has been given. Okay. And then you have to find out the volume fraction of the fiber. So, how do you got the volume fraction of the fiber? Using these equations, which are again very simple equations. Sigma A is nothing but the load being experienced by the fiber by the area of the fiber. So, that you get, so area of fiber is basically V f multiplied by A c. So, you can get that V f equals to, ultimately using this equation you can get the value of V f, and once you get the value of V f, obviously V m you can get. Once you get the value of V f and V m, and then you have to find out the value of F m, because F f is given, you try to find out the value of F m using the same equation for matrix now. So, V m multiplied by sigma m multiplied by A c, and you get the value, because all now, V m how much, sigma m has been already given and A c also has been given. So, the value of F m you get as using this equation, the value of Fm you get. So, that means you can see here the load being experienced, again you can see here this is a problem which you are trying to solve, but from these numbers if you see that the fiber is experiencing obviously quite higher load than the matrix. And the last portion was to find out the value of EC, EM and EF. Now, EC is nothing but sigma C over epsilon. Epsilon are same for composite matrix and reinforcement because it is isostrain condition. So, now how do you get the value of and that sigma, that epsilon is already given in the problem, epsilon is given as 1.56 multiplied by 10 to the minus 3. So, that you can use, and how do you get the value of sigma C is basically Fc over Ac, and Fc is basically Fm plus Ff. Now, Fm you know, you calculated, Ff also given. So, you get the value of Fm plus Ff over Ac is also given and epsilon is also given. So, from there ultimately you get the value of epsilon Ec. Similarly, you can get the value of Em by using this simple equation of sigma m over epsilon m, and sigma m is given. So, you can get the value of Em. Similarly, you can find out the value of Ef as well. Okay. Let us try to solve another problem, okay, which would be again little bit difficult than the previous ones, but let us look into those problems. This problem says, let me go into this problem. This problem says that in an aligned and continuous carbon fiber reinforced nylon 6 composite, the fibers are to carry 97% of the load. Okay. And the data has been given that so this value, this 260 is basically the E of the fiber EF, and this is EM. Similarly, the sigma F and sigma M, sigma FU actually, sigma FU and sigma MU have been given. Okay. So, using the data provided, determine the volume fraction of the fibers that will be required. Okay. So, what has been done here, okay, is that, let me show you what is. So, ultimately from there FF over FM is equals to EF VF over EM VM, and then EF VF over EM into 1 minus VF. Okay. So, this can be actually shown FF over FM. FF is nothing but sigma. So, if you are not getting this equation directly, then FF you can convert into sigma and A. So, sigma FF is basically sigma F over AF. Similarly, FM is equals to sigma M over AM, and then sigma you can convert into the value of epsilon, elastic modulus, because epsilons are same isostrain condition, and from the AF value you can divide by AC, you get VF, and then AM over AC you can get VM. So, that is how you get this equation, okay, FF over FM. So, FF over FM is given already as 0.97. So, FF it says that 97% load is being carried by the fiber. So, 0.97 by 0.03. So, the ratio of FF over FM you get here, and then you plug in the different values of EF and EM, and then ultimately from this equation now you get the value of VF. So, VF, once you get the VF, one thing is interesting here, you can see here that sigma of the composite material is equals to, you can see here it is not sigma mu, but sigma m dashed. Why? Because at the failure of fiber, matrix would not be experiencing its ultimate stress, it will be experiencing stress lower than its ultimate stress, which is sigma m dashed. If you remember those plots which I have done few times earlier, it will be sigma m dashed multiplied by 1 minus Vf, and the value of sigma m dashed have been given. If you see here sigma m dashed, it says assume that the matrix stress at fiber failure is 50 MPa. So, that is given. So, this 50 MPa has been given now. So, 50 MPa multiplied by 1 minus 0.258, which is basically the volume fraction of the fiber. So, basically again now it is nothing but plugging in the values once you figure out this equation. Okay. So, sigma CL, that is basically sigma the matrix stress, the composite stress at failure would be equals to this much. Okay. So, that is how you solve the different problems. Okay. We have some more problems which I will be giving you in the slides, and you can go through those problems and you try to solve those problems. Okay. I have given some hints here to solve those problems. So, you can understand, try to understand this problem, and then it is a different problem than the previous ones. So, it is better you solve it, and then some hints have been given here. So, I think it will be easier for you to understand, and you can solve the problem. Okay. So, with that I would like to conclude this class. In fact, I have some plan later also to solve some problems for you, so that again some different problems for you, so that it becomes easier for you to understand the other problems and solve those problems. Okay. So, mostly we have talked about solving the different problems using the transverse loading equation and longitudinal loading equations. Okay. In the next class, okay, so far now we are talking about continuous fibers, but in reality it is not always continuous fibers. So, in the next class we will talk about discontinuous fibers. Okay. So, let us conclude today's class, and I meet you in the next class. Thank you.